Hello, you rate, and welcome back to the Air Around Us Lesson 4. So the question today is, what gas makes lemonade fizz? We've all had a good gulp of lemonade and a good burp after it. Also, we've also seen a video like this.
Mentos, and the reason we choose Mentos is because they have this chalky-like quality to them.
Right.
What we want is
That's
we want,
like coating on
yep,
the outside.
and we're just going to put them into the test tube, so they go down to the test tube like this. So there's your test tube. Got it?
Okay.
13 Mentos, just in case you're counting. All right, so there it is.
Some people probably are.
So now let me open this up here, and yours, you can open yours up as well. All right.
Okay.
So
What's in
and we're
Mentos?
just using Diet just because it's less sticky when it finally there's a disaster.
Oh, when there is a good one.
All right, so now here's what's going to happen. We put the card on, we turn the whole thing upside down. We're going to put it over the top. We're going to position it so it's right over the top. You got it? So right there on the
Okay.
edge.
All right.
Now, when we pull it out, those are going to fall real fast, and when they do, all of the bubbles that are inside are going to rush to them, and we might see a little eruption. Are you ready?
Yay!
All right, so
Let's
we're
go.
going to go 3, 2, 1, pull. Ready?
Okay.
3, 2, 1, pull. Good. Ah!
Woo!
Is that a mess?
So what do you think happened there? What gas do you think is in lemonade? And why have you chosen that gas? Oxygen, nitrogen, carbon dioxide. Which gas do you think is in lemonade? And why have you chosen that gas? Write it down, please. So which gas does actually make lemonade fizz? In this experiment, we're going to be using a special homemade lemonade called Jonazade. If you're doing this in class, I'll be telling you not to drink it. Seriously, do not drink Mr. Hancock Jonazade. Okay. Label up the equipment we're going to use in your booklet. Do that now. We're then going to add 1 spatula of white powder to the sidearm tube. Measure and slowly pour lemonade onto the filter funnel and collect the gas. Much like in the video, we were using the Mentos to cause a reaction in the Coca-Cola. We're using a white powder to create a reaction and remove the gas from Mr. Hancock's lemonade. It will bubble up through the sidearm tube, be delivered into an upturned test tube where we'll stopper it and collect it. That's the plan. Label up the equipment now. Air Around Us Lesson 4. What gas makes lemonade fizz? Into the sidearm tube we're going to put 40 centimetres cubed of Mr. Hancock's special lemonade. If we do this in class, do not drink this lemonade. In the bottom of the sidearm flask we've got a special white powder, which is going to make Mr. Hancock's special lemonade fizz a bit quicker. A bit like when you shake your bottle of lemonade at home. So we break off the gas from the lemonade, go along the sidearm tube and bubble up into the boiling tubes and displace the water. We're doing this in class. Do not drink this lemonade. It's Mr. Hancock's special concoction. Will do you no good at all. tubes of gas from lemonade. So we have now collected 3 tubes of gas. We know they're either oxygen, carbon dioxide or nitrogen. How are we going to identify them? I need you to make a plan. What tests would you carry out to identify which gas is in these tubes? Also, what do you expect to see in these tests? So write that down under question 1. What tests you'll carry out to identify this gas and what you expect to see. Do that now. You're going to test for oxygen with a lit splint and a glowing splint. You're going to test for carbon dioxide with lime water, and by process of elimination, 2 negative tests means we have found nitrogen. Okay. We expect that we will see a positive result for oxygen, being a bright flame and a relit splint. A positive result for carbon dioxide will be milky or cloudy white. A positive result for nitrogen will be negative tests of the other 2. Let's go see what we find out. So here we have the 3 tubes of gas we collected from the lemonade. So okay, first test, we're going to test with a lit splint to test for oxygen. Lit splint going into the test tube. If it goes out, it is not oxygen. The splint has gone out, it is not oxygen. Next, we'll test with a glowing splint. This will also confirm whether or not oxygen is present. A glowing splint will relight in the presence of oxygen. It didn't, it went out. It is most definitely not oxygen. Final test for carbon dioxide. Cloudy result will be carbon dioxide. A clear result would be nitrogen. Lime water going into the gas. Slight reaction on the way in. Give it a shake, we've got a massive positive reaction of a cloudy or milky reaction in lime water. That is carbon dioxide. So, in our results, we can make a results table. You've got some lines to write in your book. So the lit splint was a negative. The glowing splint was a negative. We can say definitively the gas is not oxygen. The lime water was a positive result for carbon dioxide, meaning it is not nitrogen. The gases we have in lemonade is carbon dioxide. So, all the way back at the start of this lesson, you made a prediction what gas you think is the lemonade and why. If you chose carbon dioxide, well done. Why do we use it? Well, we use carbon dioxide because it's a natural part of the air and it does us no harm. It is also very easy to carbonate something. It is very easy for carbon dioxide to dissolve into a liquid. All the other gases. Nitrogen. Nitrogen doesn't dissolve in liquids very well. However, we do use nitrogen to keep things like packets of crisps fresh. So when you open a packet of crisps, beside your crisps is nitrogen. Oxygen. We don't put oxygen into liquids. We could oxygenate them, but oxygen will actually support a fire, a flame. So that would be a bad idea. So we use carbon dioxide. Does us no harm, it's cheap and easy to get, and it is easy to carbonate liquids by getting carbon dioxide into them. That's why. So you have one task left, and that is to complete homework 2. And we shall check that at the start of the next lesson. Thank you very much, and we'll see you next time.